Hello friends, this is Wasim and today we will learn scalar data types in Rust. So what is scalar data type? So scalar data types are the data types which stores a single value like signed int, unsigned integer, float, character, bool. So we will discuss all these different types of data scalar data types provided by Rust. So let's get started. So let's take an example. Suppose let a equal to 10. If we do not mention a data type, if you see the compiler is automatically reducing its type as i32. So here I means in signed and 32 is the size in bits. So this i32 is not coded added as a part of code. If we want to add it, we have to double click, then it will get added. But this is a compiler plugin feature which can tell us like which data type compiler has automatically deduced. So this is the Rust plugin which we use to do development in Rust. So you can also install it. So by default, Rust assign, if you create any data type which is integer, by default Rust will assign deduce that type as i32. If you assign anything as float like this, by default Rust will deduce that variable as f64, like 64-bit float. So we can see this due to the extension. But if suppose if we do not want to use the default data type provided by Rust, we can explicitly mention that I want i8, like signed integer 8-bit data type, and I can store 10 inside it. So this works fine. So there is a minimum and maximum value you can store in a data type based upon the size of that data type. So if you want to store more bigger value, you have to uh, create the data type with a higher number of bits, and you can know about lower and higher bound of that data type, range of data type, by this formula. So for signed integer, it is 2 to the power n minus 1. So n is the size in bit, 2 to the power n minus 1 minus 1. So if it is 8, so 2 to the power, so minus 2 to the power 8 is, so 2 to the power 7 is 256. So we can store 256 till 256 minus 1 is 255. If we want to, sorry, so here we took 2 to the power 8, so it will be 128 and 127. So it is like 2 to the power 7 will be 128 and minus, so minus 128, and 2 to the power 7 will be 128 minus 1, which is 127. If we want to store anything above 127, like if we want to store anything above 127, we will get an error. So let's clear the previous messages and do cargo run. So let me make it last. So if you see, it is saying like literal 150 does not fit into i8 data type whose range is 128 to 127. So Rust compiler give us error whenever we want to store anything which is going beyond the range of the data type, which is a good feature. C does not provide this feature. C gives us warning, but they never stop us from compiling. So this is same with I16. For I16 also we will have maximum and minimum. So if you want to store maximum of this I16 in this variable A, there is a shortcut. So you can type I16 colon colon max. Yes. And if we print, it will, you can see that it has stored the maximum of I16. So for maximum of I16 will be 2 to the power 15 minus 1. Oh, let me print this. And let me clear and do cargo run. So if you see that maximum value we can store in I16 is 32767. So we can do the same like in many time at many times during competitive programming or during real time programming, we have to store the maximum and min values. So this is a shortcut, like you can also store min by replacing this max with min to any data type in Rust. So if I do cargo run, this is the min you can store in I16. So anything which starts with I, any data type which starts with I will can store minus and plus like signed and unsigned integer. But if we want to create a variable to store only unsigned integers, we have to denote with u followed by the number of bits. And if we want to store the minimum in U16, we will get 0 because it cannot store negative values. So if you see, we get 0. So if you see, Rust provide us I8, U8, I16, U16, I32, U32, I64, U64, I28, U28, and isize, usize. So this isize and usize are the architecture dependent data type. So based upon the computer architecture, be it be 32-bit or 64-bit, the size will be defined. So if your PC is 32-bit, then it will be I32 equivalent to I32. If your PC is 64-bit, then it will be I64. Same here, U64 and U32. Now let's move to floating point. For floating point, we have two types, F32 and F64. So if I do not mention anything and we assign floating point, by default compiler reduce it to F64. But if we can explicitly make it F32. So F30 x64 stores somewhere around e to the power I sorry I forget, but it is a very big number, and F32 is the smaller number. Now there is a major difference in character which we have in C, C++, and Rust. So in Rust, the character is not ASCII type, it is a Unicode scalar value. So we can store these kind of emojis in in Rust character. If you see, and if we print it, we will be able to print those emojis. So if you see emojis getting printed, so the character size will be 4 bits and it can store a lot of different types of character like special symbols and Chinese characters, emojis, and other stuff. So this is a little bit different, but yeah, actually many advanced programming languages were supporting this. So Rust also started supporting this. Now other thing we have is Boolean type. So bool is for true and false. So it has only two value possible called true and false. So we can assign true. Sorry. So yeah, and if we print, we'll get true, and if we assign false, we'll get false. So if we do not assign anything to variable, right? Let a equal to nothing. If we are assigning nothing, so at that time, unit type is assigned. If you see, compiler is saying that this is a unit type. So unit type is equivalent to void in C. So it means nothing, like nothing is assigned. So if any function which is not returning anything, we can return unit type. If a variable doesn't have anything, compiler will assign unit type to it. So I'm done for today. See you in the next video.